Okay, so today we're going to look at a PowerPoint about mass. And now the tricky thing with mass is that it is not the same as weight, okay? So we're going to first look at what is mass here. Mass is the amount of matter or stuff in an object. So the difference there between mass and weight is that mass and weight, mass is the amount of stuff, and it's not going to change no matter where you go. So weight, your weight changes whether you're on the moon or on Earth or on Mars, because weight actually depends on gravity. It's gravity times your mass, okay? So yeah, as you lose mass, you lose weight, but mass will stay consistent no matter where you are. The metric unit is grams, or kilograms is sometimes used. If you're asked for base unit, it is grams. We use a balance with a fulcrum to measure it, okay? Now, this is a balance with a fulcrum. It's not a very good picture, but what that means is that the fulcrum is like the middle of that teeter-totter, okay? So if we put something super heavy here, this side will go down, and then as we equal out this weight, it'll balance itself out, okay? This is called a triple beam balance because there are 3 beams there. Now this is kind of the old school way of measuring something's mass. And we need you to learn how to do that in case we ever need to use them. However, most of the time we will use electric balances, which is a little bit easier. So again, another triple beam balance. We've got the 1, 2, 3 beams. We've got the pan that we put our stuff in, and we can see the fulcrum is right here. Notice the fulcrum isn't necessarily in the middle. So if we put something heavy here, this end's going to go down, and then we have to move these weights over to balance it out. Oh my goodness, lots of names there. Don't worry about knowing all of those names, but you should know how to read one of these. Okay, so here's what we're going to look at. We have 3 beams. The first beam is in increments of 10. The second beam is in increments of 100. And the last beam is not only in increments of 1, but it's actually divided into 0.1. So we have to add the numbers shown on each of these beams. Okay, so this is 50 plus 300 plus, it looks like 7.3, okay? And that would give us 357.3 grams. So this next one, we've got 50. We don't have a marking on the 100, which means it must be back here on the 0, and we have 3.9. So what would that mass be? If you said 53.9, you would be correct. Here, we have a marking at the 400, nothing on the tens bar, and then we're at like 5.55. Okay, so 5.5, 405.5 or 405.6 because we wouldn't actually measure out that far. So when we're adding these up, we simply add up the numbers shown on each of the 3. Weight then, like I started to mention, is a measure of gravity. So if gravity changes, your weight is going to change. On the surface, so let's find the Earth. If you weighed 150 pounds, on the sun you're going to weigh 4,185 pounds. But on the moon you're only going to weigh 25 pounds. And that is all because of the change of gravity. Okay? So the metric unit for this is Newton, which is grams per meters squared. Okay? Though you can also use kilograms, so we could have grams per kilogram squared also. We use a spring scale to measure it. So this is a spring scale. If you've ever gone fishing and used one of these, this is a spring scale. You put the fish on there, and it pulls down based on the weight of gravity. Okay, there's another fish being held up by a spring scale. So that should have given you a good explanation showing how mass and weight are different. You have some practice there on using a triple beam balance. Go ahead and do that. Check your work with your teacher's keys, and then move on to the next set of notes.